So this is our third energy lesson, and we're going to be looking at how energy is transformed, but that it's always. So here's our law of conservation of energy. So it's similar to other laws you've learned in other science classes. And so we have the law of conservation of energy that states that energy cannot be created nor destroyed, but can be converted to other forms of energy with no loss of energy. So in the picture, we have the sun. And the sun has nuclear energy because there's nuclear fusion happening, and that is causing helium gas to be formed, which gives us light and heat energy. The light energy helps heat our atmosphere. It also causes photosynthesis to happen in trees, which gives us chemical potential energy in the form of food, which we can then eat, and then we can use that to do what it is that we do. So whether it's breathing or heart pumping, exercising, anything like that. So here's our formula for mechanical energy. So the sum of the kinetic and gravitational potential energy is what mechanical energy is. And so here we have our one formula that just has EK plus EG, or we can write it out in its long form, which is really how you're going to be using it. So you're probably going to use that equation more often. Sometimes though, you're only given information to either help you calculate kinetic energy or potential energy, where the other one is going to be zero. And then you can use this formula again later on in the. So here's our first example. While on a trip, a traveler drops their 0.85 kilogram camera. So we have a mass, and it falls 1.6 meters to the ground. And this question, part A, is asking us, what is the camera's gravitational potential energy before it falls? So really we're just looking for our EP here, which is going to be mgh. So we'll put in our information and solve away. So we get 13.3 joules. And then if we go back and we look at our sig figs, we only want 2 sig figs, so we're going to round to 13 joules. Part B asks us the same question, but what is the kinetic energy before it falls? So before it falls, we can assume that V is 0. So if you put anything into your equation for our kinetic energy, you're going to get 0 for our kinetic energy. So we don't really have to do any work for that. Part C says, what was the speed of the camera traveling just before it hits the ground? So now we're talking about h is 0 meters. We're looking for our V. Our mass is the same. And we know our energy. We calculated back in our first example because we have to start. That's the only energy we have, that 13.3 joules. So that transformed into kinetic energy. So we're going to use the extra sig fig when we're doing this calculation. And so because it's just before it hits the ground, so we're going to assume it's like millimeters off the ground. So if h is 0, then EP is 0. So we don't have to worry about that. So we're going to take that 13.3 joules, and it's all kinetic energy. So then if we want to rearrange, we would be doing 2 times 13.3 divided by our mass and square root it to get our V. So let's go ahead and put the rest of our numbers in. So we get V equals 5.6 meters per second. And we want the 2 sig figs. So there we go. So in that example, we had to calculate our initial energy, and then that energy can't change because we can't lose energy. So it can just be transformed from one form to another.